Alright, so I've been trying some experiments using um, the large coil on the outside of this big rotor. And I was talking to Sky, and it makes sense that it doesn't work well on the inside here because of all the eddy currents. So on the outside here, uh, it's getting a direct pulse. But what I really wanted to show you was this little coil right here. I've tried many coils up against here to uh, do a pickup or some induction, and I have this little coil hooked up to a bridge rectifier, and placing this coil up against here, and this has an iron core which makes a huge difference. I'm getting 15 volts DC. Of course, it's rattling the the um, the big rotor, but I am getting 15.8 volts DC out through the bridge rectifier. Let me see if I can show you really quick here. So I've got the bridge rectifier right here, and I think you can see the meter from there. Yeah, 15.9, 15.3. So I get the most voltage out of this little tiny coil, which came out of I think it came out of a microwave. And all the other coils I've tried don't produce that much. And I think it's because in the other coils I've tried, the wire is much bigger. This is a really fine wire, but it also has an iron core. Because doing the same thing with the same size wire without an iron core, like this one here, produces about 4 volts. So the iron core makes a big difference. So yeah, I tried putting this beast up against it. Did not produce a lot of voltage. Maybe more current because it is a much thicker wire. I think this is like a 22 or 23 gauge. But yeah, I think what I'm going to do though is I'm going to take this guy apart and build a better rotor. Let me slow this down so I can show you. See, I've got the acrylic. This is mainly for Sky. So these are the 4-inch neodymium magnets, N45s, I think. And I have an acrylic end here and one on the other side with the cutouts. You know, goes like that. Bum bum. Fill it up with resin. And so I got myself a new shaft. Beautiful, much bigger than this one. Stainless steel shaft, 8 millimeters. And I got some 8 millimeter ID bearings. I'm trying to get my hands on a old printer because those, I'm told that those shafts are the best. But I think what I'm going to do is I'm going to take this beast apart. It's served me well, but it is a beast, and it's not, this little shaft here, I mean, I can even bend it here. It's just not conducive for a shaft this big. So I'm going to probably saw this in half, or saw it next to each one of the magnets, see if I can get the magnets out without breaking it. It's probably not going to work, but I'm going to try it anyway. Anyway, I was using the JL94 circuit, which works freaking great. It's my new favorite circuit. It's great because it's like a Bedini, but much simpler. You can get back EMF off of it. And I think what I'm going to do is I'm going to put a shaft inside this little one here and see what kind of voltage I can get off of it. I don't know what current I'm getting off of this bridge rectifier setup. I'm not going to go into all that right now. It's probably not a lot. Anyway, ciao. So, really quick question out there for anyone who cares to respond to this. What would be the easiest way for me? Remember, this is a solid block of resin with 6 N42, 45 magnets in there. I think they're 4" by 1/2" by 1/4". And they are resin in there. What would be the easiest way to extract these? I was thinking about just cutting it and seeing if I can wedge it out, but I'm thinking there's got to be an easier way. I don't think I can use heat because heat destroys the magnetism. I found that out the hard way. Yeah, so I want to reuse these like I showed you earlier with this beautiful stainless steel shaft, 8mm, and the new bearings. And I'm going to use it in, well, I can't use it in this one, but I'm going to put it in PVC instead of this so I can get a more accurate rotor, a more balanced rotor, because this thing looked balanced when I brought it out, but yeah, this little skinny 1/4", cold rolled steel it just doesn't cut it. So, any suggestions out there? Thanks in advance. Really quick, I thought I'd show you. This is my Bedini circuit that Sky made for me. I wanted to see how it would work with this rotor. I can't, if I tilt it up, it screams even faster. I've got to be really careful. Yeah, I got to be really careful. That is a beautiful rotor. Let me see if I can put this down. Yeah, I've got to be really careful. This is a bifilar coil with an iron core. I'm going to have to rework this base so that I can turn this sideways and have it going in this direction here, so that I can easily set up another experiment where I can mount this securely, because playing with it like that is really dangerous. This thing, these magnets weigh a lot, and if this thing were to collapse on me, it would not be good. Anyway,